Grade, we're going to look at proportional relationships. So that means being able to consistently identify a rate of change, a unit rate, and that means using the slope of the equation or the situation. Then we're going to relate the steepness of the line to a higher rate of change. So the higher the slope, the higher the rate of change. And finally, we're going to be able to compare outcomes from a story problem using information from the problem. All right, Math Marbles, let's look through this problem together. Here I'm going to look to see if the graph is actually proportional. So the information I'm going to look for is 1, does it start at the origin? In other words, 0, 0. 2, I'm going to look at the shape, is it linear? And 3 would be, if I can see 2 points, find the K for 2 points. Now, I'm not going to use this third one in this example because the only clear K I have is this one over here. That's the only clear point I can see. Any of the other points just aren't on an easy place I'd be estimating what they are. So I really can't use this one. So I could only see one clear point. But looking at the rest, I can see that it does start at 0, 0. And I could also see that this is linear. So let's support our claim. The graph represents a proportional relationship. It begins at 0, 0. There is a constant rate of change, creating a line graph that increases. And if I wanted to even go a little further, I could figure out what K is because we know. So if this was this equation represents our graph, y equals kx, I could divide by x and do y over x to find k. So I can use that 1 point. This is the challenge part. I only have 1 point here. So in this point, I have 0.3 and the x is 0.7. So that is equal to k. The rate of change is 0.3 over 0.7. And that would be it. That would be enough information. Again, if I had another point, I would take those 2 points and see that both of them simplify to the same K. But hit pause and jot this down into your notes. This is how I would give at least 2 pieces of evidence to support a claim. Ryan is running on a treadmill. The graph shows the proportional relationship between the time he has run and his distance. What is Ryan's speed as a unit rate? So let's start by just saying what the problem is asking. We want to know the distance Ryan runs per minute. That is his speed, distance per minute. Let's organize our facts. We can see there's a point on the graph and there's several points on the graph. Matter of fact, I can identify 4 at 10, 1, 22, 33, 40, and 4. So we could already see a common pattern happening here with time and distance. And the other fact that we have is our K is our constant rate. So we're going to use that in our equation y equals kx. So here's my plan. I'm going to just select 2 points on the graph, probably the 2 simplest points, the ones closest to the origin. And I'm going to use K is equal to y over x. I'm going to substitute my x and y into that formula for both points. Then once I substitute, I'm going to simplify and solve for K. I'm going to look for that K in both equations. Once I have that, I'll know for certain what his speed is per minute. All right, we're going to use our plan. We're going to first identify 2 points. This is definitely linear, and we're going to use our relationship y equals kx. And our k here is our constant rate of proportionality, but it is also our unit rate. All right, so let's look at what this looks like. I'm going to also rewrite my formula to figure this out. So K is equal to Y over X. I'm going to use my very first point, which is 10.1. And so if Y is 1, X is 10. So that is equal to my K, 1/10. And that makes a lot of sense. That means in 1 minute, I'm only going 1/10 of a mile. That makes sense because look, in 10 minutes, I'm going 1 mile. So if I want my unit rate, meaning at 1 minute, how far am I going? I'm only going 1/10 of a mile. Let's verify this with another point. So I'm going to use 22. So K is equal to, here's my Y is 2, my X. And that also simplifies to 1/10. So that is my unit rate when I'm using 2 points on a graph. The unit rate is 1/10 of a mile per minute. All right, so hit pause and jot this down into your notes. Here's our second problem. Charles needs to fill a large water tank with water using a hose. He has 2 hoses from which to choose. Water flows through each hose at constant rates. The graph below shows the amount of water in gallons that flows through hose A based on the number of minutes used. A total of 110 gallons of water can flow through hose B in 10 minutes. Which hose has a faster water flow rate in gallons per minute? So that's important, gallons per minute. What is that rate? So pretty much we want to know which hose has the higher rate in K. So that's what we're going to look for, which one has the higher one, but it has to be something I can easily compare. So I'm going to use that 1 point that I can clearly see on the graph, 212, and I'm going to use that rate that's given in the word problem, 110 gallons in 10 minutes. And I'm going to find a rate for both, gallons per minute. Once I have that, I'm going to find a unit rate. So I'm going to simplify them to 1 minute. That way I can compare them very easily. I can see how much water goes in both hoses in 1 minute, and whichever one is the higher number is the one that has the highest rate. Okay, hit pause and jot this down into your notes. All right, let's start with A and B, and I'm going to use this point for A, which is 212, which represents 2 minutes to gallons. All right, and I'm going to use our equation. So Y equals KX, and I'm going to rewrite that into K is equal to Y over X. We're going to substitute our points. So Y is 12, X is 2. So 12 over 2 or 6. So in our first hose, the rate is 6 gallons per minute. And in B, we have the information 110 gallons and 10 minutes. So what we're going to do is we're going to simplify that. We're going to divide both of them by 10. And that will give me 110 divided by 10 is 11. And 10 divided by 10 is 1. So, or just 11 gallons per minute. All right, so now we have both of them, and we can do a very easy comparison. Now that they're both in unit rate form, we can figure out which has the greatest rate, and it is B. Clearly B. So let's write this down in our bottom part. Hose B has the greater rate of 11 gallons per minute versus hose A, which has a rate of only 6 gallons per minute. Okay, hit pause and jot this down into your notes.